Next, we will see the problem valid parenthesis. This is the straightforward problem, and this is very important in terms of interviews also, because the people will ask you to test how you can use the stack. So for that purpose, this will be used. So let us try to understand the problem. Here actually you have given a string and which contains strings like this, like open bracket, close bracket, and square bracket, and then floor bracket. So these are the characters they are giving, and you need to see that each open and close has in a sequence or not, in the right order or not. Then it is true. Otherwise, you can return a false. For example, this one, example one, open and close are matching, so it will true. And here also it is matching all types of things, it will true. And here it is not matching, there is no equivalent open and close braces characters here, so it will be false. Here also there is a equivalent open and close thing, it will be true. So basically what we can do here is, let us take this one. Okay, yeah, try to use these characters. I think with a small character only we can draw that actually. So we can take here, basically we can go for one um, solution only. There is no brute force or something like that. We can go for directly using the stack, and it will be O of n time complexity. This is the solution we will try today. But data structure will be stack, which again like maximum of O of n time, O of n space complexity, space, and this is the time complexity, right? So basically we can take the stack. What we can do is, because the problem says that there are different kinds of characters, right? So what we'll do is we can use one map, basically, which will have the close equivalent to open, like this. And right, so basically we'll try to use this map to store this open respect to close, respect to brackets, and its respect to close and to start things. Okay, and we can also use the stack. uh, for example, let us take one example like this. This is the valid one. Okay, and in this valid one, so initially what we can do is we can try to check the map this value. Okay, that value nowhere there, because we are not interested into that. So it will if that is not there, if this character not there in the map, then we'll directly try to push this into the stack. In the stack there, this will be there. Okay, for now. And then the next iteration we'll try to get this string actually there in the map, right? This string is here, and it equivalent thing is this one, and the top of the stack and this string are matching, right? If this is the case, what we can do, we can minimize the stack size to stack size of, basically we can reduce this one, this stack will become empty again, right? We can remove this. Basically we can remove this particular matches, so the stack is empty. We will check that the stack is empty, then it is a true. I mean that string will be actually valid parenthesis. Okay, let us take one more example. For example, this thing, right? Similarly, okay, let us take a second example. Example 2 here. I am trying to take this kind of characters. Okay, let us see Again, same map we can use, and as a stack will be initially it is empty. um, when I'm trying to read this particular first character, and this is nowhere, this character open thing nowhere as a key in our map, so it is it will come here and it will try to fill the stack with this name, this particular thing, right, with the open bracket. And then I will try to iterate the next character, and the next character I have a key in the map, and its respective character is open thing. I'm looking for the open thing in the stack on the top element, which is not there, right, which is not equal to open bracket. So in this case, directly I can return false. Okay. So this is the what we are trying to implement. This will be like as I mentioned, O of n time complexity, and also O of n time space complexity, right? Okay, let's build this one using Golang. So as I mentioned, we'll try to take uh, the stack as I did in the example. So here stack up byte will take, and also as I mentioned, we'll take the map to store the key values, and we will predefine this. We know the characters will be open bracket and square bracket and flower bracket. So basically what we can do is we can, for close bracket equivalent, we can try to keep open one, and similarly for the brackets also, right, and we will take the square bracket as well. Okay, so these are the like a map we'll use, and now we'll try to iterate the entire string, whatever string we received here. Yes, so for that what we can do is we can take the character of range from yes. As I discussed, we're looking for the map that particular character is present or not. For that what we can do is we can take the character followed by is present or not from the map of uh, byte of ch. Okay, so if the character is present uh, in the map, that means um, we need to check the length of stack, basically length of stack. If this is the case, if this particular close bracket or braces or flower bracket anything is present, then we need to check this particular stack length should be greater than 0, and stack last element should be equal to the character whatever we reach. This is actually open, right, should be match. If this is that is the case, then we can minimize the uh, we can remove the last element, basically. Okay, I mean top element from the stack. Okay, if this is not the case, then if that is not there in the thing, that means there is a wrong there is a something wrong with the parenthesis matching actually. Okay, we'll return the false immediately. Otherwise what we can do is we can try to add the element into the stack, append stack byte of that character whatever we received. Okay, once we came out of after parsing all this character that the given string, you have to check the length of stack should be 0, because the elements, if something is present, that means we have a starting element which is extra, which doesn't have the respective closing character. That's why stack size may be more than 0. If it is 0, that means there are equal number of starts, and right position, I mean at the correct position there is a ending also. Okay, let me run this code. Okay, there is a typo. Okay, it is accepted. I think it should succeed with the submission. Okay, cool. So basically the time complexity for this is, as I mentioned, um, time complexity will be O of n, and space also we are using, right, actually. um, the stack also and the map also. Map, this is anyway, map is a const, because there are three characters, it is a constant. Only we can consider variable part, that is space complexity will be again O of n. Okay, that's it.